Please note that this is a sponsored event and any opinions expressed are those of the presenters and do not necessarily reflect the views of ASCE. ASCE also asks that presenters and participants refrain from discussions surrounding competitors and pricings of products and services. And now, without further delay, welcome to AI versus manual approaches. Digitizing Land Use and Transportation Asset Map Data, sponsored by Ecopia AI. We
Thank
are
you very
thrilled. Oh, hello.
sorry, Robin.
I was just going to say, we are thrilled to have Ecopia AI with us today. This is their first sponsored webinar with ASCE, and we hope to have many more in the future with them. For those of you who are new to our sponsor, Ecopia AI is a geospatial technology firm that leverages advanced artificial intelligence to build a digital twin of the world by converting high resolution geospatial imagery into comprehensive, accurate, and up-to-date HD vector maps for use in data-driven decision making across industries. The Ecopia team will be hosting three organizations today who are actively using their national asset base map data collected from the latest aerial imagery to win more proposals, improve project estimates, and accelerate project timelines across several applications. And now I would like to welcome Bill Singleton, Vice President of Architecture, Engineering, and Construction at Ecopia AI. Over to you, Bill.
Thank you very much, Robin. We're very excited to have the opportunity to host today's sessions focused on AI versus manual digitization techniques, and how some of your peers, which will be represented in a few minutes here on today's call, are using some of this AI generated data to help accelerate project timelines, and help to improve the proposal process. So, really excited to be to having the opportunity to speak to everyone today. We are going to focus on three main areas, but there's a number of different applications that our data has been supporting across the civil engineering industry. And we'll be focusing on some of the specific applications surrounding transportation planning, stormwater management, and also environmental planning. So really excited to have the opportunity to speak to you today. I've been with Ecopia AI for 11 years. I'm part of the senior management team here. And really my sole responsibility at the organization is to help get the latest geospatial asset data into the hands of any of our civil engineering partners. Really, my main objective is I want to help make your lives easier, in particular with the data acquisition process, and hopefully, if not eliminate, significantly reduce the need for nasty manual digitization of different kinds of imagery that's available in the marketplace. Um, in terms of our organization, Ecopia AI has been around for 13 years, using deep learning to extract highly precise vector geometry from the latest aerial and satellite imagery across North America, but in over 100 countries across the globe. We are not a software service. Really, the data that's being provided and that's going to be talked about today is we have already decided to go out and pre-build a number of the about 80 different features, and making them available to the community, and creating a website where people can come on, interact with the data for free, understand what kinds of data sets they may need when open data sets aren't available, and just pull down exactly what they need in order to support their specific applications. So really looking forward to today's conversation.
Hey, Bill, could you go ahead and put it in full screen in
Yeah.
presentation mode? There you go.
Yes, thank you very much, Robin. So in terms of today's agenda, I'm going to quickly touch on just a little bit of a background of our organization and what we're doing in terms of our initiative to extract a number of different features across the globe, but more specifically here in North America. But I really want to hand everything off to the wonderful guest speakers that we have in today's session. We are going to be, I'm shortly going to be introducing members from the Black and Veatch team who are going to be talking about some of the ways that they've used some of this AI-derived data to accelerate some of their stormwater financial modeling. I'll then hand it off to the Kimley-Horn team, and then we'll wrap up with David Wasserman, who'll be talking about the ways that he's used our data for transportation planning. Towards the end of session, I am going to quickly show just the website that we're throwing all of the data up on so that anybody can come on and take a look at what we've pre-built across the country for a number of different verticals, and so that you can get a better understanding of what's available. And if you need anything, then you can pull that down. But really, I want to focus on some of the question period towards the end of today's session, where everybody who's attending today can ask questions of the panel that we have. So just at a very high level, I'll do a quick summary of what our objectives are as an organization. Over those 13 years as an organization, we have been using our deep learning models to extract information from in over 100 different countries. So our models are trained to work in a number of different kinds of terrain, identifying a number of different features. When we initially got our start, our team was focused on some basic features that were typically manually digitized and more difficult to automate, things like building footprints and road networks. But what we've really been focused on over the last 5 or 6 years is using higher quality aerial imagery to extract a much broader portfolio of features. And that's really where we've been focusing our time over those last few years, is extracting everything from different kinds of impervious surfaces to support environmental and other water and stormwater applications, to extracting a number of different assets in the public right of way to support transportation planning when public sector data is either out of date or does not exist, to a number of other building attributes, depending on what you might require for a number of other visualization requirements or building requirements. This is just a quick list of some of the organizations that we've had the opportunity to work with and we're supporting with some of our data sets. We are looking forward to talking about some of the many different applications that the same data, relatively the same data, can help support. If you're extracting all of the impervious surfaces, you're most likely collecting everything from sidewalks to driveways. And so a lot of the same data sets can serve multiple purposes, and looking forward to discussing that a little bit with everybody on today's call. We've had the opportunity to support 5 DOTs across the country. We've been working with Illinois DOT for 5 years now, updating a statewide map data set for their organization, and have had the opportunity to work with over 50 MPOs, but really been focused on working with all 3 levels of government. Once this data is created, there's a lot of different ways that it can support a number of different organizations. So looking forward to touching on a number of those applications in a few minutes here. In terms of why we're going out and pre-building everything, we just saw so many people recreating the wheel, and that's where we want to be able to use the power of AI to be able to go through all of the different aerial and satellite partners and be able to pre-build a number of base map data sets so that they're available for a number of industries. When we initially got our start, we were working to extract a lot of building information for the insurance industry. But once you start creating 3D buildings, that same data can support 5G propagation in the telecommunication industry. And then you start extracting a number of different assets surrounding properties. And it was just a natural fit for our team to start providing a lot of this data to a number of other verticals, including architects and civil engineers like yourselves. So really looking forward to being able to showcase how these same data sets can support a number of different applications. I think we all understand the problem. Open data is great. It's free. It's something that we want to try to leverage wherever possible. But this was a project that we recently had the opportunity to support across Baltimore Regional Transportation Authority. And so this is just 2 of the 80 assets that we're identifying across the continent. And so this was focused on active transportation planning, so identifying sidewalks and crosswalks across the entire transportation authority. And so this was the data that was generated by some of the city staff and also junior engineers. And so you can see here really focused on downtown regions and major corridors, versus having a more holistic look at all of the sidewalk segments that can be captured across an entire region. And so really want to we want to fill in the gaps when data is not available. And that's really where AI can have a huge support to the industry, is being able to use image recognition and be able to extract a lot of these important features to help cut down planning, to help cut down and make proposals more accurate, but also whenever you are engaged with a client, being able to accelerate those project timelines. But we can also go one step further. AI can go one step further and not just identify the geometry and the segment data, but it can also uh, do advanced classification. So identifying whether a surface is paved or unpaved, and that can be helping some of the environmental use cases. Versus identifying the width of certain features, just to try to help out with a number of with a number of other applications versus just doing the strict identification of the geometry. So, just in terms of some of the data sets that will be talked about today, our team is pulling together a number of different aerial imagery sources. And that's one of the ways that we can help you, which I'll talk about on the next slide, is really being able to take all the great imagery that's being captured by a number of different providers, whether those are aerial, oblique, satellite, and being able to identify features from all the great imagery that's being captured. And then we'll quickly be touching on some of the transportation assets that you can use AI to identify. So a lot of centerline data and a number of different more precise features like paint striping and curbs a little bit later in the presentation, to focusing on some of the land cover applications. So uh, that will be highlighted by some of the work for Black and Veatch and Kimley-Horn. So identifying a number of different 2D land cover pieces, and then also discussing some of the 3D work that will be generated across the country, and that will be made available to everyone. Just to quickly touch on some of the processes. So, our team is collecting data from all of the major providers, whether that's Nearmap. We have multi-year arrangements with Nearmap, Vexel, EagleView, a number of the largest aerial providers, and we're distilling that information on an annual basis so that it can be made available to all of our partners in the number of verticals that we recently mentioned. But one of the most important things is we're more than happy to rebuild anything. So that is one of the powers of AI is we can recreate anything from a new data source. So if you are working on any projects and there is your either yourself or your end client has their own imagery source, we're always happy to take that in and recreate from whatever imagery is required for your specific initiative. So that's just one thing that we always keep in mind is we can really there is the ability now with these new AI techniques to be able to reprocess vast amounts of imagery, both going forward and backward. One of the last slides that I'll touch on today before I hand it off to the Black and Veatch team is we've been doing this for a very long time. And even we are always triple checking our results. I'm sure a number of people on today's call have had different experiences using some of the latest automation techniques to for image identification. And we are always selfishly, we always triple check our results because we always want to make sure that we are providing results that are ready to use by our peers and our partners in this industry. And so that's really what we try to focus on is making sure that are using automation for as much of the process as possible, but also triple checking everything so that we can ensure the highest degree of results. And we always try to, and we're focused on having 95% accuracy with everything that we're putting out the door. And so we also want to, the other reason that we're always triple checking everything is that we always want to improve our training data sample set. And that's one of the ways that we've been able to reinforce the capabilities of our deep learning is by always continually training it whenever we take on a new project over a specific kind of region, identifying a specific kind of asset, and just continually improving that process. And just like I mentioned at the beginning, so all of the data that will be discussed today, we want to provide it in vectorized format that goes right into the applications that everybody on today's call here is used to using today. So whether you're an Esri user or whether you're working with Bentley or Autodesk, we want to provide data that can go right into your environment so that there's no need to relearn or retool or to integrate any new software into what you're working with. So I'm really looking forward to today's session. What I'd like to be able to do now is I'd like to pass it off to Taylor Holliday, who's going to talk about his experience working with some of our data sets and go over his initiative on the East Coast.
Great. I'll take over the screen sharing here. I believe you all can see my screen. So we're going to go with it. Hi, everyone. So I'll be talking about maintaining stormwater utility data with Ecopia's impervious data capture. I am Taylor Holliday. I'm a senior analyst with Black and Veatch. I'm based out of Oregon. I'm with the Infrastructure Advisory Division, and so we assist with financial side of utility management, including stormwater utilities, which we're going to talk about today. So first to start out with, what is a stormwater utility? So it is a dedicated funding mechanism to pay for a community's stormwater management program. Much like an electric, gas, or water or sewer utility, stormwater utilities assess a user fee based upon the property owner's usage of the system. So an example, how much stormwater a property generates from sources such as street roofs and other impervious surfaces. From an operational perspective, you are identifying the costs and services provided. So stormwater utilities have the goal of reducing flooding, protecting water quality, and complying with environmental regulations. There is a need to maintain that infrastructure, so you need to maintain that funding source. And then you need a surrogate for stormwater runoff because you can't meter stormwater. And we'll kind of come back to this in a later slide. So to kind of get a general perspective, there are over 2,000 stormwater utilities nationwide, with the first being established about 4 decades ago. There is a lot of growth in stormwater utilities across the country. An area that we're seeing a lot of growth in is Georgia, New Jersey, the Northeast. And these utilities require routine maintenance to keep, because these communities are ever changing and growing. I'm sure many of you have been outside and you see developments going in every day. So that changes stormwater dynamics quite quickly. So if those new developments or changes to land use aren't captured, you're leaving a lot of money on the table when it comes to that stormwater utility. So as I said earlier, unlike other utilities, there is no meter for stormwater. So impervious area is the most common basis for defining stormwater user charges. So about 87% of stormwater utilities use that impervious area as the basis. Another 25% or so use gross area, and then there's another 2% that use some other method. If you add up all of your math, you're probably thinking, wait a second, that's above 100%, and that's right, because some utilities will use a mixture of both, so impervious and gross area as a basis. Some key considerations going into that are availability of reliable data, ongoing data management, cost and effort to obtain, and that customer expectation as well. So as stated, impervious area is the most common basis for defining stormwater user charges. So where does that data come from? So typically we'll use aerial imagery, LiDAR data, existing digitized impervious feature layers, some building and other improvements from tax assessment systems. And then methods in which we obtain that data will be from either manual or AI supported capture like Ecopia, runoff coefficients or imperviousness factors, statistical sampling, which is typical for residential analysis, and then a combination of one or more of those approaches. And so then here we have the impervious area capture for the city of Charleston. Charleston, excuse me, had an established stormwater utility and fee, but in this project that we worked with them on, the city wanted to migrate billing systems and in the process update their impervious area data. That's a lot to get done, and things had to be done on time and across two very unique counties to get those bills out on time. So having Ecopia do this helped us out a ton because we could spend more time on those migration issues and less on the impervious area capture. So as you can see, here's two images of Charleston where Ecopia was able to capture that impervious area data. And then you'll see the different colors. That's because there are different land use types, and that's actually really useful because the fee will be based off of those types as well. And so then we wanted to quickly highlight another advantage is that Ecopia data was broken into 14 different land use types. So those on the left side of your screen there. We narrowed them down to the city's desired amount, so which was 4. But we can always go back and change this if policies in the city change without having to do a full recapture in that moment. So say right now unpaved driveways, parking, and sports grounds are currently under partial impervious, and that does not apply to the stormwater fee. But say something were to change in the city where that policy is that should be charged 50% of what other impervious services were, we could easily go back and update that pretty quickly, which in a manual process, that would have taken a really long time. So it's super helpful to have that all kind of ready to go. And again, yeah, Ecopia was able to get this in to us in about a couple weeks, whereas like doing it manually would have taken months. So it really helped us kind of focus our effort elsewhere on the project to really get that billing system migrated over. And yeah, it was great. It worked out pretty well. So I ran through that super quickly. Just wanted to give you a pretty broad overview and then spend a little bit time later today during questions. But if you have any questions, feel free to reach out to me. I have my email over there. You can also scan that QR code, and that's my LinkedIn. You can message me there. But yeah, thank you guys for listening. Hope to hear from you.
Thank you so much, Taylor, for the summary. Yeah, we're really looking forward to supporting the B&V team. What we also find with stormwater utility fees is something that does need to be kept up to date on a more frequent basis, just as obviously as certain communities are changing every year. And so being able to sort of keep track of how impervious surfaces are either growing or shrinking in certain areas of the communities, we're looking forward to being able to help there. So I'll now introduce the Kimley-Horn team. Yeah, I'll let you take it away.
Thank you, Bill. Get our presentation pulled up. My name is Melissa Duyar. I've been with Kimley-Horn for 13 years, and I sit in our Chicago downtown office leading our surface water team. Anna Zielinski is joining me on the phone as well. She's also on the surface water team, and we focus on primarily floodplain modeling for a variety of client types. The project that you're going to hear about today is for a solar project. So we do a lot of work with renewables clients as well as public sector clients as well. So what you'll see on the screen is just a snip of the project that we did a sensitivity analysis for in HEC-RAS 2D hydrologic and hydraulic modeling software. So you can see there that water has been applied, rainfall has been applied to this gridded system and then allowed to flow throughout the model. These models have layers such as like terrain, land cover, which is used to develop infiltration rates as well as friction values. And then finally, the rainfall is applied. And Anna is going to talk about one of the snippets of this sensitivity analysis.
Thanks, Melissa. So as Melissa mentioned, we did a couple different scenarios for our sensitivity analysis, but we'll be focusing on the land use today because we were using Ecopia's data for that. So we were looking at how affecting and changing the land use types changes the Manning-Zen and infiltration layers and impacts the depth results for these solar projects. So we have that outlined in red there, and then the full pink area is the model that we were looking at for this like smaller watershed. So we were looking at 3 different data sources for these land use layers. We downloaded data from the National Land Cover Dataset, which is publicly available, which can be used for like preliminary studies, but it's not as detailed and it's pretty blocky. Then the next layer that we were looking at was doing a hand delineated layer, which is where we go in and manually edit and add these shape files and assign the land use types based on aerial imagery and the terrain. And then finally, we had the data provided to us by Ecopia, the AI-generated land use. So this is in central Illinois. So most of this model area is cultivated crops because it's pretty rural. Most of the change that you'll see within these layers is within the streams, the forested areas, and the urban areas. So now we'll talk a little bit more about the Ecopia layer specifically and how this affected our timeline in our results. On the left, similar to the Black and Veatch team, we had to look at all of the land use classifications given to us by Ecopia and then match that to a TR55 land use match and assign SCS code and Manning-Zen values to have this compatible with the HEC-RAS simulation and the model. So there's a lot of details like paved driveway, parking, road intersections that we kind of generally split up into streets or impervious areas because they have the same or similar Manning-Zen values. So in order to affect our results, we are trying to like trim it down to the data that we really need. So it takes a little bit of time there to assign those correct values, but definitely a lot faster than assigning and editing those shapefiles by hand. So here's a closer look of 2 different areas within our model comparing the AI-generated Ecopia layer versus our hand-delineated detail that we added ourselves. So on the left, you can see those forested areas are a little bit wider, and then the hand-delineated on the right, those green shapefiles are the streams that we went in and added based on our preliminary results. So you can't always pick up those with imagery, but based on the terrain and our preliminary depth results, we were able to add those in. And then on the bottom is a college, which is more of like a urban impervious area. So those footprints of the buildings were definitely a lot more detailed, captured all of the sidewalks versus our hand delineated layer was more general about like where the forested and impervious areas were. Then we wanted to add the streams because that's what we're looking for with these hydrologic models.
So here's a comparison layer of our hand delineated results versus the Ecopia results. So you can see that the orange and red values are areas where the Ecopia results led to about 3 to 12 inches of difference on the solar site itself. We use these results to determine how high to put the solar panels as well as how much erosion we might expect around the piles that are supporting the solar panels. So just adding that detail from the Ecopia data, especially around the urban areas, certainly helps. Whereas there are some areas where there was limited detail in the streams, like Anna said, where we could add additional detail by hand that would lead to a little bit more accuracy.
So our final takeaways from this is that the 2D models for these hydrologic conditions are sensitive to Manning-Zen and curve number changes, so it's very essential for us to be delineating those streams, make sure we're getting the correct Manning-Zen values so that water can be trapped in that channel. Again, the NLCD data, which is definitely the fastest because you just have to download it and then clip it to your site, but it's pretty blocky, and so we generally would only use this for a preliminary study, and then the hand delineated is kind of the best practice that we were using before, but it's definitely the most time consuming. This project specifically was 12 square miles, but sometimes our model, like the smaller watersheds, can be over 100 square miles. So that definitely takes a lot of time to be editing those by hand, which is where the AI generated Ecopia layer was very useful, having that layer already set in, and then just adding streams on top of that layer streamlines the process a lot more. Yeah, thank you. If you have any questions, feel free to reach out to Melissa or I. And then I'll pass it over to Bill.
Thank you very much, Anna and Melissa. We're really excited to be working with the Kimley-Horn team in a number of different areas and being able to support all different kinds of project sizes. So I want to thank you so much for the summary and looking forward to handing it off to our last speaker today. So I'll invite David Wasserman, who we've been working with for a number of years now, and looking forward to hearing more about what you have to say in the transportation planning space.
Thank you, Bill. So I am going to be talking about AI-derived cross-sectional databases and their applications. I hope everybody can see my screen. I'm going to proceed with it. All right, excellent. And I will proceed as if that's the case. All right. So for those unfamiliar with Alta Planning Design, I just want to give some background on our firm. We are a multidisciplinary firm focused on creating sustainable communities across the United States. We bring together engineers, planners, designers, and behavior change specialists and graphic designers to facilitate investment in sustainable mobility that is safe, equitable, and resilient to change. So I just want to give quick background to who we are for those unfamiliar. And, you know, a lot of people have shared a lot of case studies as well about how Ecopia data can be used for flooding and different types of land use analysis. And for us, we're very excited about how we're seeing new ways of digitizing right-of-way assets, ranging from tree canopy to sidewalks and crosswalks, and the different benefits that this provides, whether it's being done by Ecopia or being done by deep learning tools, for example, in the Esri environment. But the benefits of this can be wide-ranging, can provide a scalable view of context and constraints. It provides a repeatable method for digitization that can be done in successive years. And it can enable scenario planning and multimodal enhancement of different types of existing models, and can be very helpful for asset management and provide different inventory benefits. But these AI-derived assets are not perfect. While it can accelerate a lot of good work in transportation planning, appropriate applications will depend on developing good quality control procedures to make the most of this type of data. But one application that I'm excited to talk about for this type of detailed asset data is the development of cross-sectional databases based on the HD vector extractions of the roadway that Ecopia can provide. And a cross-sectional database is just a GIS database that assesses the horizontal profile of the roadway based on the discrete lane-based extractions provided by Ecopia. And so often the first step in how we develop these cross-sectional databases as part of our work is we will get Ecopia data and then review it and make sure that the cross-sectional alignments make sense across the study area. But after that, we develop left to right profiling lines that look at the cross-section and identify how different roadway elements are laid out across the street, as you can see by these points along the HD vector extraction example above. And then we consolidate this data into the roadway center line so that each segment is more or less stacked with the same centerline ID so that different queries can be made about the roadway for different applications. So once we digitize this information, it can be further consolidated into a JSON-like format to enable a cross-sectional view of every segment. And web maps were featured in Analysis, as I will illustrate for our major case study for Greensboro's MPO's Safety Action Plan. And one area where these comprehensive right-of-way databases can be used to aid bicycle and pedestrian planning is helping with the computation of bicycle and pedestrian level of traffic stress scores. For those unfamiliar with these scores, these are comfort metrics that identify whether segments have appropriate infrastructure for its context to provide a high comfort experience and safe and comfortable routes for all people of all ages and abilities. And typically our goal with this type of assessment is we're trying to identify different pathways, for example, where communities can build out a more connected set of low stress pathways for pedestrians and cyclists, typically within the LTS2 or LTS1 range, if we're trying to accommodate children and people of different ages and abilities. So in Greensboro, we leveraged the cross-sectional database that we developed across all the major arterials in the region to develop comprehensive measures of bicycle and pedestrian level of traffic stress. And this was informed based off of where there were sidewalk gaps, the number of lanes, the buffering of sidewalks, presence and type of bicycle facilities, speed limits, and other right-of-way factors that we were able to extract from these cross-sectional databases. And once you have a comfort metric like this, it can have a lot of applications. We can use our understanding of these scores to adjust network analysis by the network quality of every segment and how it can influence the user experience of pedestrians and cyclists. And we know from behavior change research, the presence and quality and context of these facilities has a strong influence over the choice to make a trip by walking or cycling. So this type of network quality assessment can be combined with origin destination. Can be combined with origin destination data to help identify high impact gaps across the active transportation network. And while this example is from Cupertino, California, rather than Greensboro, it illustrates how Alta has combined network quality and big data to identify where high impact gaps in a travel network can be. Beyond this, coming back to Greensboro, Alta, of course, integrated this right-of-way data directly into our safety analysis across Greensboro's MPO region. One way that we did this was, for example, integrating it directly into our risk factor analysis, where we look at the relationship between the propensity for severe collisions and contextual factors such as the type of center turn lane or crosswalk spacing. All the elements of the Ecopia data, the data collection helped us look at, and the cross-sectional database played a critical role in that process. So as part of our analysis with Greensboro, for example, we identified that the number of unique cross-sectional elements increased on major arterial roadways, and they tended to also have a higher share of severe collisions that appeared on those types of facilities relative to their share of centerline maps in the region. This type of contextual database helps inform where there might be unique risk factors that we might not have thought of at looking at, for example, in a region such as Greensboro. But beyond looking at street complexity, we looked at a number of other right-of-way factors to develop what we called our risk factor map, where we looked at multiple different contextual factors, such as through lane counts, curb to curb widths, and lane widths, and identified how they could all help us figure out if there were different streets with high shares of severe collisions relative to their relative to the length of centerline they applied to, and overlaid all those different factors to develop risk scores for bicyclists, pedestrians, and motorists, with this example being the pedestrian risk factor analysis results. Beyond this, there are some other notable applications we have found for this type of cross-sectional database and right-of-way data that we have explored or will be exploring in the future. One is for the Phoenix Active Neighborhoods project. We were able to apply a cross-sectional database to help identify where there might be available right-of-way or reallocation to other uses if lanes were narrowed to what existing guidance suggests could be the minimum for things like medians or through lanes. And then we visualize this excess right-of-way to evaluate where there might be space for different types of improvements, like maybe adding a buffer to a bike lane that already exists, or other types of modifications along the way. So this was an interesting application of the database to see if there's any space for right-of-way reallocation. In Sacramento, we've applied this type of asset data to create what we call the Tree Opportunity Index, where we combine the identification of criteria related to need, such as the lack of tree canopy, and existing heat exposure to those related to possible planting areas, such as where there was pervious land cover or on-street planter areas without tree canopy. We used a very small hex grid to capture the street-to-street variations to help identify these opportunities, and it translated to a pretty highly detailed database where we were able to identify where there was this combination of need and opportunity for plantings across the city of Sacramento that could be investigated further. And then also, as that we were doing this as part of an active gaps assessment, we also looked at where we identified active gaps and where there might be synergies between investments in active transportation and the potential availability of areas to engage in more tree planting. And beyond that, this type of right-of-way data can help us create potentially at-scale visualizations of how the right-of-way is laid out, and integrate into tools such as City Engine that help you get a cross-sectional view of the right-of-way and visualize it in 3D and engage with different scenarios in a particular street. So this is one area where we're looking to see what can be done and whether or not we can use these types of cross-sectional databases to enable at-scale visualizations of different regions right-of-way and create different 3D models, for example, of how streets could look, and enable more scaled up scenario planning where you can have this connection between the analysis that you're doing based on these type of databases, but also different visualizations of how the street could be allocated in the future. So that is that brings me to the end of my presentation, and I will pass it back over to you, Bill.
Thank you very much, David. I always learn a little bit more every time we have the opportunity to present together. So I want to thank you for going over all of those different examples. I know we've had the opportunity to work together for sure for a few years here. So I've had the opportunity. I think the timing is working great right now. There's one last thing I'd like to show all of you, but I have had the opportunity to take a look at some of the questions that have been rolling in. Do encourage you to start putting any questions that you might have for either myself or any of the presenters as I sort of wrap up this last portion of today's presentation. But I think we can address some of the earlier questions with some of the last things that I'd like to show you here. One of the things that we're really excited about as an organization, as I mentioned, we've decided to go through and we've had the opportunity to work in over 100 countries. And I know there was a question that came up there. So happy to discuss any of the sort of the satellite imagery and sources that we're doing. But I would love to show you the website that we've created that we want to provide access to everyone on today's call. Or any of your colleagues. The whole idea is we're going to be going through and identifying all of these assets from the latest aerial imagery, regardless of the source. A lot of the data is collected from the latest near map data. So you're in for 87% of the population, which near map covers, you're likely getting one or two updates or one or two looks at or captures a year, which is great because we want to keep everything up to date. And so what I'd love to be able to do right now is I'm going to share my screen one more time. And can you see my screen?
Yeah, it looks great.
Perfect. So this is a website that we've created. Like I said, it's something that we want to be able to provide people access to, complimentary access. And I'll provide a link at the end just in case you're interested. Really, what we're doing is inviting all of our civil engineering partners here as another alternative to get access to vector asset data from the latest aerial imagery. I know there's a lot of open sources that are available out there, but some of those can sometimes be out of date or incomplete. And so this is where we wanted to create something where people could come in, interact with everything we've created, get a sense of when it was built, and what kind of features there are. Take a look at the accuracy before you make any decisions as to pulling that down. After anybody is invited, they'll have access to three databases that we've created. Our 3D land cover has been supporting a lot of the environmental, stormwater, water applications that were mentioned on today's call. We have our advanced transportation feature section, which is a little bit more focused on center lines, data that's being used for permitting, utilities in applications like AutoCAD or Autodesk series of products and Bentley. And then we do have some of our 3D roof stuff, which I'll touch on right at the end. So you can get a sense of some of the more advanced 3D roof geometry that's going to be coming out, which is being used to support visualization and site design. So there's a little bit, there's a different applications for all of the different spaces here. But once you have access, you can come in and take a look at anything that we've built out across the country. Our whole objective is we are going to have complete coverage of the lower 48 by the end of September. Right now, we've been really focused on some of the urban environments because we keep getting requests there. But the intention is to use all of the different aerial sources that we have, using Nearmap and Vexcel, Eagle View for some of the cities, but also working with organizations like Hexagon to make sure that everything is filled out across the 3.12 million square miles of area, whether it's our land cover features or whether it's some of our transportation, our 3D building stuff. And so you can come in. This is San Diego right here. And you can take a look at all of the features that are in either of the databases, and you can take a look at their accuracy. You can play with the opacity here. And what you'll see below is the source imagery that the data was created from. If you are ever interested in, because this is a question that comes up with a lot of the organizations that we're working with. And if you just give me 1 second, I'm just going to minimize this. If you are ever interested on what the data was built off of, and so you can see here, just playing with the opacity a little bit, so you can get a sense of the accuracy before you decide to start pulling anything down. But you can always take a look at the coverage and vintage here. And so You can see here a lot of this is built from last spring's data set, but we are going to be doing our update for the urban areas as the spring flights are complete. And you can zoom out here and sort of get a sense of whatever that month and year is for anything that we've built out. So it's just another function helping you try to navigate all of the different aerial providers that are out there. Want to make sure that we're providing things that are either from 2025 or 2026 imagery. For anybody who signs up, anybody can pull down free square mile of data. So if you are interested in just pulling down a sample so that you can use it in your own environment, whether it's Esri, Autodesk, or Bentley, like I mentioned, feel free to pull that down. Every single individual at your organization who signs up will get a free square mile of data. But then what I'll also do is just quickly head over to give you a sense of the advanced transportation features. And so it can be a little bit cumbersome to take a look at everything when it's turned on. So I'm going to turn off some of these features. This is the road marking and curb data. This has been used predominantly for permitting. So you can see zooming out all of the data that we're pre-building across all of the urban centers. But we also have a number of centerline data sets. So whether you're looking for different kinds of bike lanes for more active transportation, or maybe you're looking at center lines for traffic, all of this data is going to get pre-built across the country. Right now, I don't have the centerline data on. I'm more focused on the paint striping and road markings. So you can get a sense of everything that we've done before you decide to start pulling anything down. And one of the advantages that we've created, and I'm not going to go into any pricing or anything like that, is we have, whenever you do place an order, really the whole idea is we wanted to create a transparent model where you can take a look and pick just the features you need, and then you can get a quick estimate, just so that you have the visibility and you can make your own decision. So whether maybe we do want to digitize internally, what we're finding from and the feedback we're receiving from a lot of the partners who are using this so far is, yes, there's a cost savings versus doing it yourself, but more importantly, it's the time. People are able to increase the throughput of whether it's getting data for proposals, confirming that estimates are accurate, because sometimes might not be as accurate in terms of how much assets you have to maintain or improve. To after you've won a project, we want to pull this data down or show our customer that, hey, listen, we have a way of getting this data very quickly. Should we just grab this and we can keep on moving? And so that's what the main objective of our organization is we want to help eliminate that manual digitization that your teams are having to do right now whenever open data sources are not to the quality or the requirements of your project, and just give you another option. So I want to be able to take a look and see what's available. I want to see the accuracy of it, and I don't want another application I have to manage. I just want to grab the data I need for the project that I'm working on and keep on moving. And so that's really what the main idea of this website is. And I really am looking forward to being able to providing access to anyone who might be interested. The last thing I'm just going to quickly show, because this is something that we're very excited about, and the data set's much larger, and so it takes some time. You can see here in our land cover, in our 3D land cover, you can always go to the 3D portion by using the button in this bottom corner. We have 3D buildings across the entire country that are LOD, level of detail 1.3, so multi-level flat surfaces. And so you can get an idea of this right here. In case you want to include that in any of your upcoming projects for visualization or as I mentioned, site design. But we are going to be coming out, and we've done this over 100 cities so far, but the intention is to have 400 cities sometime in the summer. Is our advanced so this is more for advanced visualization. So identifying, it's moving from a level of detail 1.3 to level of detail 2.3. So just understanding pitched roofs and more roof geometry. And so feel free to, when you log on, you can come take a look at any of these data sets. And if there's something that can help support any of your initiatives, welcome you to take a look at it and sort of make your own decision as to whether this would be helpful or not. So With that, I just want to be mindful and provide a little bit of and provide time for questions because definitely excited to respond to anything that you might have. I know we quickly touched on some of the imagery stuff, but I can open that here in a couple seconds. As I mentioned, we want to help. The main thing that I would love for everyone to take away today is we just want to create another option for data for to help improve data acquisition workflows to help with proposals and estimates and a number of and your project timelines. And so with that, I'm going to open it up for questions.
All right, Bill, we have a lot of questions in here. I did have a question for you, though. Did you want me to launch that poll that you had?
Yes, yes. Sorry, just as we go into questions, I'd love if everyone could take some time. Just it's a single question. As we sort of queue up the question period here. Would love to learn a little bit more about your interests. We're always building data sets across and building and keeping data sets up to date. And so always interested to learn more about specific assets that people are interested in, because we are already looking at all this great aerial imagery, but also getting a better understanding of where this might be most helpful for everyone.
All right. Well, as people are completing that poll, let's go ahead to the first question I have here. Thank you. Great presentation. Has your team done any historical analysis using older imagery sources?
Yes, yes. So that's something that we always love the opportunity to be able to work on. We have a number of initiatives that we've done, in particular on the West Coast, in particular to forestry, a tree canopy, and also looking at some transportation assets. So there is so much information and a wealth of knowledge that's locked up in satellite and aerial imagery that's already been captured that was used for a particular purpose, and then we never had it was never used for any other alternative. And so we have access to all of that great historic data. And so if anybody's interested in doing either an environmental analysis or tree canopy change or just having a better understanding of how certain subdivisions have evolved over time, we're more than happy to not just do change detection going forward, but also taking a look at a number of different data sets that have been created going back to even 2010. So always interested to be able to support those applications.
All right. And here's another one. Are there any other applications that this data has been used to support across civil engineering industry?
Yeah, so in terms of some of the new applications that we're starting to see, a lot of applications in utilities. While there's certain assets that are a little bit more difficult to extract, in particular, even if you do have access to 3-inch aerial, um, there are a number of other assets that we're about to standardize. Some of those are storm drains and manholes, which is something that we've been hearing that there's not a significant or a consistent database of in many cities across the country. And so being able to provide that data along with things like curbs and some of the paint striping has been helpful to reduce drafting times for permit applications and construction. So really looking forward to being able to support those going forward as well.
And will that include underground utilities as well? There's a question about that.
Yes, so great, so great question. We are focused on on surface and above. And so we can identify egress points, like I just mentioned. But most of the time when we're working with some of our partners is we will be focused on national asset extraction on surface and above. And then our partners or civil engineering partners will merge other data sets to that, so they will find other sources and merge some of the subsurface um, um, identification to our other data sets. And so just trying to help wherever we can with the surface and above.
Okay, and here's another question. How often is your satellite photo database getting updated?
So that's a great question. We have multi-year arrangements, not just with the aerial providers, because we got our start working with satellite providers. So we work with Vantor, which is the rebranded Maxar, which was the old Digital Globe. So they have a fantastic database that's updated every single day. And so we are building out our global data using both Airbus and Vantor imagery. And so that can be a little bit more on a project by project basis, but we have done a number of projects. We recently just did 3D buildings for all of rural India, so about 300 million buildings. So there's a number of different applications that we can support, and really looking forward to being able to support um, uh, data sets on any continent. Because we've had the opportunity to work across Southeast Asia, Africa, South America. So our models are trained on a number of different kinds of terrain.
Okay, and now this is a fully loaded question here. And this is from Eva Lerner Lamb, whom I know very well and adore. So this question is for you, Bill. Great presentation. Do you specify chunking rules, APIs, MCPs, and agent skills for your clients to be able to provide your data store with their canonical, verified, and validated data with minimal ambiguity?
Okay, so there's a few pieces to that, and I will do my best with pieces of it. So a lot of experience helping to conflate data sets. We have clients that well they had great data sets that they've created, and they want to merge it to our geometry because maybe you have certain metadata requirements. So we've done that. We've also gone the other way around, is maybe making sure that our geometry fits into some of the previous data that's been created. In most instances, sometimes it can be more of a nightmare to try to merge certain data sets, and that's why it's a little bit on a case by case basis, because there's varying levels of quality with a number of different data sets, and so we just want to try to get the best understanding of what is necessary for you, and can we replicate it ourselves, and then maybe we provide the whole package to you. But we always want to work with our clients to make sure that we are not throwing out hard work or systems that your teams are working with. In terms of the delivery style, so you can come onto their website, and you can either be creating custom orders if we don't have it, or if we do have it, you can just pull it down. It'll be delivered in a number of different formats. And we have our own, we have a standardized metadata sort of attribution table system that we've worked with that seems to work with most of our civil engineering or government clients, whether they're municipal, state, or federal. The one piece is if you do have your own requirements, that's something we can definitely work with you on. So there is flexibility on if you want attribute tables or specific kinds of metadata. In certain kinds of formats, we can definitely help with that. And we typically split files up because I mean, one of our largest clients is working with NOAA's Coastal Change Management Program. We're doing like a million miles of land cover extraction. So we can break the data out into either different sort of projection zones or different, we can create different shape files or geodatabase files based on specific requirements. So there's a number of different ways we can divide the data so to make it more manageable from your side. And I hope I touched on most of the pieces of it. I don't
You
know if
know,
I
there
got
is a second part to it,
and
and
David can help.
yeah, I
David,
was going to say, David, do you want to jump in and add anything?
Yeah, I mean,
Oh.
traditionally, Ecopia has generally just provided geospatial data. I think this question is very relevant for people that want to explore creating natural language queries of Ecopia data. And I would say it's probably possible to create a model context protocol or similar query uh, or similar way to query in natural language with Ecopia data. I think the trouble you would run into is you would need to basically create some type of natural language representation of the attributes and of the elements of the database that you want and manage the associations between different elements that Ecopia produces. So like how those relationships between elements are defined and conservatively defined independently. You might need to create rules for that yourself. But generally, Ecopia is a geospatial provider. They're not providing necessarily the APIs for agents to interact with per se. Sorry, just trying to cover Bill.
yeah, no, thank you, David. Yeah, and then just on that too, Ava, I saw another great question from you, just in terms of the licensing of maybe data that you're providing us, because I did mention we're more than happy to work with your own imagery. If you have your own imagery sources, we've done it both ways. So we have certain clients who bring us imagery and listen, like this is ours. We want to protect this. That's something that we can absolutely help with. So and abide by. So it just depends on the situation and what your preferences are. Typically, we will be providing licensing on the other pieces that we're pre-building, but happy to build based on your requirements. So that was another great question, Ava.
Okay, well, we are right at the top of the hour. Is there any final thoughts you want to leave the attendees with today?
Yes, please. I'd love to be able to, because I know there's some questions that we missed. We are doing a lot of international work. Divine, I see your question there too. We've worked in Ghana many times, but really, if anybody on this call, we want to try to make your lives easier, provide you another option to reduce data acquisition requirements. And so, please take a look at our website and that link that I was showing a little bit earlier here. If you are interested in just getting free access to what we're pre-building, and like I said, the aim is to have the entire all of the US done by the end of September.
All right. Thank you so much. This was an amazing presentation. And as we conclude, a sincere thank you to all of the speakers that joined us today and how they have used and showing us how they have used Ecopia AI in their projects. Also, a special thank you to our new sponsor, Ecopia AI, for making today's session possible. Their support is vital to the success of our sponsored webinar program, allowing us to provide high quality, complimentary e-learning to both current and future ASCE members. We wish everyone a safe and well rest of your day. Goodbye, everyone.